Welcome everyone to the channel. Today we are going to discuss about airplanes. Yes, it's not a part in mechanical engineering, but in airplanes there's also mechanical engineering. I thought I should share this information to give you knowledge or just to know how planes work, etc. The topic of my discussion is airplane parts and their function. An aircraft is composed of different parts. When you own a plane, you have to make sure that you not only look at the sub-parts and the main parts of the plane, but spare parts that will be used when one part fails. The aim of this section is to grow awareness about the importance of each part, no matter how small it is. Number 1. Fuselage. Fuselage. It holds the structure together and accommodates passenger or cargo. Modern aircraft fuselage may accommodate up to 800 passengers in economy class. Example is A380, Airbus A380, and up to 112 kg of cargo. Example is Boeing 747-400ER. Cockpit. It holds the commands and the control section of an airplane. Modern aircraft cockpits have a number of vital instruments for controlling the plane on the ground as well as when flying. Number 2. Power plant and undercarriage. Engines generate thrust and provide hydraulic and electric power. Modern aircraft are employed within different types of engine. Although jet engines are favored by most commercial airliners, the undercarriage, also known as the landing gear, provides a platform for aircraft to stand as well as plays an important obvious role in landing and taking off. Wings. Wings generate lift and control the airflow while flying. Designed to reduce drag at the landing edge, generate lift by its crescent and manage airflow using the rear edge. Furthermore, while gliding, that is, without engine power, the wings allow the pilot to increase and decrease the descent rate. It adjusts the angle of attack of the wings, increasing lift. Slats are fitted at the leading edge of the wings and deploying them increases the angle attack of the wings, allowing the pilot to increase the lift generated by the wing. Flap. It adjusts the camber of the wings, increasing lift. Flaps are normally fitted at the trailing edge of the wings. Extending the flaps increases the camber of the wings airfoil, thus increasing lift at lower speeds, an important feature of landing. Spoilers. It adjusts the camber of sections of the wings, decreasing lift. Spoilers are fitted on top of the wings and are used to reduce lift on a section of a wing in a controlled manner. Spoilers are useful for decreasing lift without increasing airspeed of the plane or without increasing drag significantly. Ailerons. It increases or decreases lift asymmetrically in order to change role and thus move the aircraft left or right while flying. Ailerons are hinged section fitted at the rear of each wings. Ailerons work asymmetrically as a pair. As right aileron goes up, the left one comes down and vice versa, thus make the aircraft roll right or left left respectively. Tail, the horizontal stabilizer. It helps maintain an airplane's equilibrium and stability in flight. It does so by providing a mini drag at a certain distance from the main wings, typically at the back, although it can be positioned at the front of the aircraft. This smaller wing produces enough lift to control the pitch of the aircraft and maintain its stability. Although an aircraft without a horizontal stabilizer could, in principle, fly with wings only, controlling its pitch and airspeed will be difficult. At the pitch and subsequently airspeed can be easily disturbed by air condition as soon as the aircraft pitches up. The tendency is to continue pitching up even further and decreasing airspeed. And as soon as the aircraft pitches down, the tendency then it is to continue pitching down even further and increasing airspeed. An aircraft with horizontal stabilizer, however, could be flown hands off without affecting pitch and speed. Elevators, it increases or decreases lift on horizontal stabilizer symmetrically in order to control the pitch motion of an airplane. Elevators are hinged surfaces fitted on the rear of the horizontal stabilizer. They work symmetrically as a pair. When the elevators are up, the aircraft ascends. When the elevators are down, the aircraft descends. And when the elevators are horizontal, the aircraft flies straight. The vertical stabilizer, it prevents lateral movements of the airplane. Without vertical stabilizer, most aircraft will lose lateral control, tend to slip, increase drag, and become uncontrollable. The rudder, it controls the way motion of an airplane. The rudder is the hinged surface fitted to the vertical stabilizer. When the rudder is turned to the left, the aircraft turns to the left in the horizontal plane. When the rudder is turned to the right, the aircraft turns to the right. The rudder is used to turn the aircraft left or right on the ground. In the air, however, the rudder is primarily used to coordinate left and right turns. The turns themselves are done with ailerons or to counter adverse yaw. Example, when crosswind pushes the airplane sideways. Maybe I should just generally state, in general tell you what I've been talking about. Maybe the horizontal stabilizer is used to control the pitch, vertical stabilizer control yaw, rudder change yaw side to side, elevator change pitch up or down, flaps change lift or drag, ailerons change roll, spoilers change lift, drag and roll, struts change lift, fuselage or body holds things together and carry payload, cockpit command and control, jet engine generate thrust, wings generate lift. See you next time. Consider subscribing to my channel for more informative videos.